This section covers the troubleshooting of Java EE applications. We are going to take a look at how concurrency and multithreading problems may affect the performance of a Java EE application, how memory issues like memory leaks or other problems can have a similar effect on the performance of Java EE applications, and other miscellaneous issues that may affect your Java EE application performance and cause problems like running out of disk space or similar problems. In this video, we are going to take a look at Java EE concurrency problems. What are the most common concurrency problems in Java and also Java EE? How a thread deadlock can happen? What's a thread lifelock compared to a deadlock? When do threads get stuck? Followed by demos for each of these situations. The most common concurrency problems are either a thread deadlock, which happens when multiple threads are blocked because they are waiting for each other. When the deadlock occurs, the program usually hangs or is stuck and freezing, and in most cases the only solution to that is to kill that particular process or application, or restart the application server in case of Java EE. A thread lifelock is a situation where two threads are busy responding to one another. So it's a bit like ping pong, and they keep repeating a particular section of the code, and the program is also unable to make further progress. In many cases, this also means that the only way to resolve it is by restarting the application server or the particular Java process. Last but not least, stuck threads, or also called thread starvation, is when greedy threads that consume too many resources for a long time are blocking all the others, so these threads are blocked forever, and they are waiting to acquire a resource, but they never get it, and therefore they get stuck. As mentioned, the thread deadlock is sort of an infinite loop where a lock is requested that's held by another thread. We're going to see a live demo where two lists are locked and therefore the two threads run into a deadlock. Yes, an illustration of the timeline. The lifelock is somewhat similar, but unlike the deadlock, the threads are not completely blocked. They are simply too busy waiting for each other, and they go into a sleeping state and remain there forever until they can be woken up or the application is restarted. We're going to see a live example where two classes, a cop and a criminal, are waiting for each other in a hostage situation. The police agrees to give the criminal the money only if a hostage is released, but the criminal will only release a hostage when they get the money, and therefore this causes a lifelock because none of them are willing to act first. Stuck threads can have several reasons. For example, heavy I/O and other external resources causing an infinite loop. The thread doesn't get enough CPU time because it has a much lower priority than other threads. Or threads are waiting for other resources indefinitely because other threads are notified first instead of the starving ones. When a starvation happens, the program is usually still running, but all those threads are seen as stuck. In WebLogic, there's also similar settings in other applications, but here let's take WebLogic as an example. In the WebLogic administration console, under tuning, you can configure how long to wait until a thread is marked as stuck, and also the timer interval. So here are the examples for concurrency problems. First, let's look at the deadlock. Visual JVM is starting up. and it has already detected a deadlock. So let's create a thread dump. This is similar to what you would also do on the server side. And here the deadlock is found. The only solution in this case, as it would also be in a server environment, is to restart or stop the process. The solution to this problem, at least in this simple example, is actually also quite easy. Here we have the synchronized code, which does not prevent the deadlock, and in a modified patch, by adding just a Boolean flag, this can be solved. If we run this application, you see that it creates the desired output and also terminates correctly after just a few milliseconds. The next example is the Lifelock. As mentioned in the slide, we have two different classes: the police and a criminal hostage taker. Again, it fires up Visual JVM. The application is running. And in this case, we see the two threads named criminal and police. And they're both sleeping because they block each other. Last but not least, an example for stuck threads or starvation. It's using a very simple worker class, something more complex, but also in many cases they are named worker. You will find similar classes in common Java EE containers like WebLogic, but for the sake of time and simplicity here, I'm going to demonstrate this in a standalone Java SE environment. So the thread 0 is constantly working. You also see that it's green, but it prevents all the other threads from working, and therefore they are parked or stuck in this case. And this concludes the concurrency problem demo.